We're going to look at two more functions here in rational form to try to find x and y intercepts and the vertical and horizontal asymptotes. So for each of these, we want to be able to identify what is the x-intercept or intercepts, be able to identify where the y-intercept is, any vertical asymptotes that we have, and then the horizontal asymptotes that we have as well. Now with previous functions that we've worked with, everything was factored out so we could see all the different factors and be able to find their zeros. When it's written in this form, we're going to want to factor it out so that we can find those zeros. So if I look at this, I could find factors of -1 to help me to factor out that denominator. So this would be x plus 5 and x minus 4 would be the two factors that do that. Now I've got two factors in the numerator, two factors in the denominator, which will allow me to find all the things that I need to find. If we remember from previous examples, the zeros of the numerator are the x-intercepts. So if I look at the x plus 3 or the x minus 2, the zeros of that would be at x equals -3 and +2. Those are our x-intercepts for this function. If I want to find the y-intercept, I could either go with the partially factored version, it doesn't matter. Either way, I'm going to substitute a 0 in for all the x's. So in the numerator, I can say 0 plus 3 multiplied by 0 minus 2, all divided by 0 squared plus 0 minus 20. If I simplify that, this ends up being a 3 times a -2, so a -6 over -20. Now I could leave it like that, but with both being negative values and they're both divisible by 2, I'd probably want to simplify that a little bit further. So if I divide off the negatives, it becomes a positive. If I do 3 over 10 as my y-intercept. Vertical asymptotes, I want to look back at my factored form and say, what are the zeros of the denominator? Well, the zero of the denominator here would be x equals -5. So that's one of our vertical asymptotes. The second one, I'd say, is x equals +4. So that would be a second vertical asymptote. The horizontal asymptotes, we're going to look at the degree of the numerator and the degree of the denominator. Now, if I were to take this and distribute this out, this would be an x squared plus other stuff, and then I already have an x squared plus other stuff in the denominator. And I don't really care about the extras, I care about what are those dominant powers. In this case, I have an x squared over an x squared. So if I take that x and divide it by the other x squared, I'm going to end up getting a +1. If that's what I get, my y value for the horizontal asymptote is a +1. So the x-intercepts were the zeros of the numerator. Y-intercept, we substituted a 0 in for all the x's and simplified. Vertical asymptote, we found the zeros of the denominator. Horizontal asymptote, we took the highest power of x from the numerator, the highest power of x from the denominator, divided those terms out, and ended up getting y equals 1. Well, let's do those same things over here with the second example. I want to start out finding x-intercepts. Back here we had two factors in the numerator. We got two different x-intercepts. We only have one factor in the numerator. We're only going to get one factor, or one 0 from that numerator. The of the numerator is -1, so x equals -1 is our x-intercept. For the y-intercept, back here we substituted in a 0 for each one of the x's. We're going to do the exact same thing over here. So 0 plus 1 in the numerator, 0 squared minus 9 in the denominator. I end up getting a 1 in the numerator, -9 in the denominator, so -1/9 is our y-intercept for this function. Vertical asymptotes, we found the two zeros of the denominator. Well, in order to find the zeros of this denominator, I need to factor it out. So I'm going to factor this out. Factors of -9 that add to 0 would be -3 and +3. So if I'm describing the vertical asymptotes, the 0 of this first factor would be x equals +3. The 0 of the second factor would be x equals -3. These two equations describe the vertical asymptotes for this function. And then finally, I want to find the horizontal asymptote. Horizontal asymptote. My highest power of x in the numerator or denominator is, I'm going to put the x squared in the denominator here. I don't have any x squareds in the numerator. So I'm going to put that as a 0x squared in the numerator. Because I want to compare equal powers of x. But since I don't have that equal power of x, I'm going to put it as a 0. Well, when I divide these out, x squared divides x squared, and I end up getting 0. So my horizontal asymptote is y equals 0. So when I compare these horizontal asymptotes, when I had an x squared in both the numerator and denominator, I was able to divide those out without modifying anything, and I got a number. When I didn't have that x squared in the numerator, but I did in the denominator, I ended up getting 0. And that's going to be the case every single time. If I've got more factors in the denominator than I do in the numerator, we're going to end up getting a 0 for the horizontal asymptote. If I have the same amount of factors, in this case 2 and 2, I'm going to get a number other than 0. And it's not always going to be 1. It could be something else. But that's going to help us determine the difference between getting a 0 and getting a 1 for that horizontal asymptote.